Welcome to the Advanced Electrical Testing course. In this course, you'll learn how to use your meters and tools to properly identify failed parts. My name is Lance Wiggins. I'll be your host. It's a great day to fix transmissions, so let's get started. Before we get started, resistance tests are not the best tests for checking grounds or electrical fault codes for solenoids. However, most shops have this common tool. Use the following test steps when diagnosing electrical solenoid codes. Here's an example using a single piece of wire and checking resistance from one end to the other. This is a common test when looking for an open circuit for a solenoid electrical code. We have perfect continuity. There is no open circuit. Now, if you remove the insulation in the center of the wire and cut every strand except for one, you will see the same result on the multimeter. Perfect resistance. So, if you're testing the solenoid code using this method, you will not be sufficient to diagnose the circuit integrity. The solenoid will not function properly due to the amount of amperage going through the single strand of wire. The next step would be to check the circuit for load. This is accomplished by switching your meter to DC amps. With the multimeter set on ohms, move the negative lead to the ground. The meter should read OL, out of limit. Remember, the circuit must be isolated when testing resistance, so both ends of the circuit must be disconnected. Now, we know that there is no short to ground that could be causing a solenoid electrical fault code. When grounding the meter, always use the battery ground. Never trust grounding the meter to something metallic on the vehicle. Run a lead from the battery ground to the multimeter. Another problem that could set an electrical solenoid fault code would be a short to power. This is a common issue that can set solenoid codes. Switch the meter to DC volts and leave the negative lead to battery ground. Turn the ignition key on with the engine off. Then recheck it with the engine running. There may be times when you see voltage on the circuit when the engine is running and no voltage with just the key on. This is the best way to test the true integrity of a solenoid or any other electrical circuit. For that matter, it can be any load, like a solenoid, a fan motor, or fuel injector. Set the meter to DC amps, in the range that best fits the amount of amperage we expect on a circuit. Attach the ground lead to the battery negative post. Place the positive lead on the negative side of the solenoid, which is the direction of electrical flow in the circuit. Using the previous Ohm's law shown earlier, if the solenoid resistance is 3.8 ohms, the battery voltage is 12.6 volts, the amperage should be approximately 3.3 amps. Use the following tests when diagnosing solenoid electrical faults. Switch the meter to DC volts. With the battery voltage going to the solenoid circuit, whether it's from the computer, ignition, or jumping wire lead using a fusible link to protect it from a short that could burn up the circuit. The negative side to any electrical circuit or load. There will be some residual voltage left over. There should never be more than 0.1 volts. Some factory manuals may say 0.3 or 0.4 is fine, but we like to see no more than 0.1. You can jump a ground to the circuit to see if it will drop lower if there's more than 0.1. Electromagnetic interference, or EMI, is an AC ripple effect, also referred to as electrical noise, is more common in today's vehicle. The best test for this is to set the meter to AC volts. Ground the meter to the battery and place the positive lead to the battery connected at the alternator. With the engine running, it should read no more than 0.5 volts AC. Quick test for EMI is to unbolt the battery feed. No need to unplug the connector to the engine controls. It is always best to add a ground to the alternator housing. There is usually a threaded hole to the housing marked GRD or NEG. See the diagram above. Must use a short 10 to 12 millimeter shaft bolt with a lock washer. Ground the alternator housing to the battery negative, not the engine block. To check a speed sensor, the gear will have to be turned while monitoring the voltage change on the meter. The voltage should change from source voltage to less than 1 volt, whether you're testing a sensor on the vehicle or right on the bench. The test is the same, except you will have to provide voltage to the sensor on the bench. When testing a 3-wire Hall effect sensor with a driven gear, set the meter on DC volts. When testing a 3-wire Hall effect sensor, it would be better to monitor the voltage change using some type of graphing meter. The test results should be the same. Since this is a DC voltage signal, it will be easier to see the voltage change monitoring a square wave signal rather than a digital signal. Swipe the magnet back and forth past the sensor pickup to create a signal. The test results should be the same. The same test can be performed on a 3-wire Hall effect sensor without a driven gear. These type sensors use a magnetic pickup. The only difference will be to use a magnet. The 3-wire Hall effect sensor will have supply voltage, signal, and ground connection. The 2-wire Hall effect sensor will have only a supply voltage and signal connection. Internally, the sensor will have a capacitor where the 3rd wire would be for a ground. The signal is the same as the 3-wire sensor. Whether the sensor is on the vehicle or on the bench, set the meter to diode test. With the sensor disconnected, place the positive lead of the meter on one terminal and the negative lead on the other. Note the voltage signal. Now, switch the leads and the volt value will remain the same. A 2-wire permanent magnet type pulse generator speed sensor produces an alternating current, AC signal. There may be times when you are not sure if the sensor being tested is a 2-wire AC pulse generator type sensor circuit or a 2-wire Hall effect. When the leads are switched on the second test, the voltage value will change. When testing a 2-wire Hall effect type speed sensor, keep the meter set on the same diode test. A normally closed solenoid will exhaust fluid flow when turned on and block flow when off. A normally open solenoid will work opposite of this. So, connect the power source to the positive and negative side of the solenoid. Turn the solenoid on while blowing air through the solenoid. There should be no restriction of airflow. Then, turn the power source off and retest. The airflow should be completely blocked. A normally open or closed pressure switch can also be tested on the bench. A normally closed switch will work the opposite way. Set the multimeter on resistance. Zero the test leads, as we mentioned earlier. Do not touch the test probes with your fingers. The circuit should be open and the meter will read OL when the leads are placed onto each terminal. Then blow compressed air into the switch and the meter should go to 0, equaling no resistance. A single terminal normally opened or closed type pressure switch is tested the same way, except one lead is placed at the base of the switch. To bench test the transducer, it must be powered up using a 5-volt power source. Once the transducer is powered up, it will then be able to vary the voltage based on the pressure applied to it. The TCM monitors the pressure of the clutch circuit. When the clutch releases or applies, the transducer variable voltage signal is monitored by the TCM, or control and diagnostics. Example, the pressure transducer will read approximately 0.5 volts with 0 pressure and 1.86 volts with about 110 psi of regulated shop air pressure. Of course, this is model dependent. Key on or running voltage drop on the negative ground side of the solenoid. With the solenoid commanded off, there should be a source voltage on the negative side of the solenoid. This is just a basic solenoid electrical test for any vehicle with a solenoid electrical hard fault code. The solenoid is ground controlled by the transmission or powertrain control module. With the meter grounded at the battery, or you can run a lead from the battery negative to the meter if needed. Never trust grounding the meter to something metallic under the dash or anywhere else. Remember, there should be source voltage present, just as if the solenoid was turned off. As shown in the previous test, with a solenoid hard fault code present and the voltage reading is low, disconnect the harness from the PCM or TCM and retest. If the voltage reading is now correct, there is a bad internal solenoid ground driver, partially grounded all the time, and the PCM or TCM will have to be replaced. On some systems, the solenoid may need to be energized with a fusible link to perform this test. The result should be source voltage. With the solenoid commanded on or grounded, the voltage should read 0.1 volts or less. Even if the solenoid is powered by the relay or the TCM, PCM, and grounded through the transmission case to ground, the final test to check the integrity of the circuit would be an amperage test. Repair wiring and connections if needed, or replace the TCM, PCM if all checks and tests are good. An example shown here is 12 volt source voltage divided by 20 ohm solenoid should equal approximately 0.6 amps. If the results of the amperage test reveal no fault to the solenoid circuit, then the powers and grounds to the TCM PCM will have to be checked. To test the ground side of the solenoid, place the negative lead on the positive side of the solenoid circuit. If the solenoid is ground controlled by the PCM TCM or grounded by the case of the vehicle frame to the voltage the voltage will be the same as before. If the solenoid is power controlled by the battery through the relay or ignition switch, the ground lead of the meter replaced on the negative side of the solenoid circuit. The test is the same. This will conclude the advanced electrical testing